Howdy folks, John here. Welcome to part 7 of the R2 build series. In today's video, we'll be concluding the basic electronics portion of this project. Just like the rest of R2, there are many electronic options and methods for an R2 droid build, from components to powering to control systems. In short, this video is just to give you some ideas based on the electronics I've chosen to use in my R2 build, and in no way is it an all-encompassing electronics component overview. I would, after all, hate to limit your electronics options. There are links, however, to all the components I'm using below in the description if you wanted to check them out in more detail should you decide they will work well with your R2 build as well. We'll primarily be looking at the power system, control, and drive electronics in the body because I've already covered dome electronics in part 3 and sound system electronics in part 6, both of which I link to below in the description along with the rest of the videos in this ongoing R2 build series. And speaking of links, I'm also including links to 2 wonderful free PDF publications written by Rob Howdle. First is Droid Control Systems, a beginner's guide, and the other is The World of Electronics, a new builder guide. If you're new to electronics and control systems, these are 2 of the best resources I've found in the Astromech forums to date. With all that out of the way, let's get started. Before getting into the basic electronic components of an R2 build, just thought we'd go over electronic tools and consumables. Didn't really cover it in my introduction video when I went over the tool section. Most of you into DIY already have all this stuff and know about it, but for those who don't, I'll just cover this really quick. As I had mentioned in the intro video, soldering iron, must have if you're building your own R2. Digital multimeters, definitely a must. They don't have to be super elaborate. You know, here's just a little fluke. This is a 101. It's a nice little meter for your first if you don't have one. Problem with it though is it doesn't measure current, and measuring current is kind of important because you can find out what kind of current your circuits are drawing, motors, that type of thing, so you can get the right value fuses for your circuits. And there's also, you know, a lot of R2 builds, you're going to have variable voltage regulators or buck converters, and having a digital multimeter to check the voltage as you're setting the voltage output and also current. I'll often be using 2 meters, one to check voltage, one to check current at the same time as the circuit is working. But again, it depends how elaborate your R2 is. If it's very basic, a lot of this you probably won't need. I like these little DuPont or mini PV connectors. They integrate very well with RC systems. They handle up to upwards of about 4 or 5 amps. So nice little connector. For bigger connectors, again, I'm into RC stuff, so XT60s and XT30s. You don't really need any more than 60 amps in an R2. I like these little project boards. They're just little PCB boards with plated through holes so you can solder up your own little projects that you've seen a few of already. I'm just making a little servo bus here right now, so all my dome servos can plug into just a central location, and then it will have the wire harness coming out of it. Speaking of wire, because a lot of you are DIYers, you probably don't have to worry about getting wire. You know, a trick that I use, and I know so many use, is we save all the wiring harnesses and stuff out of old electronics. So I've always got lots of wire on hand. Another way to get wire fairly reasonable is to get ribbon cable, and then you can cut it, and then you've got lots of different colored wires if you need it. Only problem with this stuff is it's fairly small gauge, but for smaller current applications, no big deal. Servo wire, of course, you can use that. Silicone wire, whatever works for you. I like these little stick-on clippies to hold the wire harnesses and such. Just makes wire management easier. Wire crimper for these connectors is a must. So here are all the electronics I'm going to be using in my R2 build, and like I had mentioned, this is just one of many ways to go about this, but hopefully it'll give you some ideas of how this stuff works together and what a lot of people are using. Again, mine is RC controlled, but a lot of this will be universal regardless of what control system. And speaking of control systems, that's probably one of the first things you're going to want to figure out in your electronics portion of your R2 build. Because I am an RC enthusiast, and I fly RC helicopters, of course, that decision was made for me. I didn't even have to think about it. I'm using an RC system. So, just a typical RC radio with an RC receiver. This one's 16 channels. I'm only going to be using 9 in my R2. I'll just quickly list what those are going to control. But of course, if you were going to go with an Arduino-based or microcontrolled control system, like the Padawan 360 or the Shadow, same idea. Basically, you'd be replacing your RC receiver with that microcontrol system. Everything else on here would also be utilized. Next thing you're going to want to figure out is your power source. What kind of batteries are you going to use and what type of voltage? You've got essentially two options, 12 volt or 24 volt systems. A lot of people are using lead acid batteries for their R2s. I myself, again, as an RC helicopter enthusiast and flyer, I've got lots of these 6S 5000 or 5300 milliamp hour LiPo batteries. And nominal voltage on these will be between 23 and 24 volts. So my R2 is going to be a 24 volt system. Reason I'm going with this is because I already had them, so I don't have to spend a dime on my batteries. I've already got lots of these. I don't know if I'm going to use 1, 2, 3 hooked up in parallel to increase the capacity. This is 5.3 amp hours. Probably going to use 2 in parallel to give me 10.6 amp hours. All depends on how long I want R2 to run. I can add packs though if I need to. That's what's kind of nice with using little packs like this. If you find the runtime is too short, just add more packs. They're small, they're light, but they are costly if you have to buy them. And advantages with a 24 volt system over 12 is when you double the voltage, you have the current. So say you had a motor that was drawing 10 amps at 12 volts. If you run it at 24 volts, it's only going to draw 5 amps. So it saves on, you can run smaller wiring, smaller connectors. The disadvantage, however, with 24 volt is the cost. If you're using lead acid batteries, you're going to need to buy 2 12 volt lead acid batteries and hook them up in series to get your 24 volts. So there's pros and cons. My plan is to mount all my electronics on this piece of polycarbonate. So everything's contained on one sheet essentially. I could remove this from R2 if I have to for maintenance or fixing something. I'm kind of hoping this will all be accessible though through the back panel of his body, so I can get to it that way. This may change, but that's the plan so far. Use what you've got, right? So downstream from the batteries, we're going to run the positive lead to a main fuse. So this is a 60 amp fuse, which should be more than enough for a 24 volt system. And you can kill the fuse if you want to. From the fuse, we're going to be driving a main power relay. So this is going to be the main relay that switches the entire power system on and off to R2 here. And the reason you want to go with a relay is so you don't have to pass a huge amount of current through a tiny little switch, which you can't do. This little toggle switch that I'm going to be turning R2 on and off with is only rated at 3 amps. So it certainly couldn't provide the power for everything. That's why you've got to run it through a main power relay. Now this thing's total overkill at 120 amps. Again, 60 amp would have been more than enough, but this is what I found on sale. So then the power will flow from the fuse through the relay to the fuse block. This is just a standard fuse, automotive blades type fuses. 6 position, I'm probably only going to need 5. And then I've got a spare one if I ever needed it. The negative from the battery will go direct to my negative terminal strip. These are actually 3 terminals, but I'll be running them side by side, so I'll have 6 ground outputs as well. So here's the buck converter or voltage regulator that's going to step down the voltage from 24 volts to run my 5 volt RC system. So, and you'd need something similar if you were running Arduino on 5 volts as well, or whatever your logic system is using. This one is rated up to 20 amps, so it's got more than enough current to drive the receiver and all the servos, and it's adjustable voltage and current. Might be a little bit overkill, but these didn't cost too much. Again, I'll have links to all these components down in the description if you wanted to check the specs out on them. Moving up, we've got the Dimension Engineering Siren 10 motor controller. You already saw this in the part 5 video where we got the dome actually working, the dome motor. It's got a very high frequency rate, 30,000 kilohertz, so you don't get any motor whine even at really low speeds. Highly recommended little motor controller on the Astromech forums for that reason. Very large operating voltage range from 6 to 24 volts. So it doesn't matter what power system you go with, this will work. And it will work with RC controllers or serial or analog. So any control system, this will work as well. Very universal little motor controller. And if you just wanted to see the quick start guide real quick, I'll hold it up and pause the video at your leisure to peruse it. Now here's our main dual motor controller for the drive motors for the 2 wheels of R2. This is a Dimension Engineering product as well. It's their Sabertooth 2x32 motor controller. So it controls 2 motors with 2 RC channels or serial or analog. Again, works with all different control systems. And R2 essentially drives like a tank. You've got the 2 wheels. If they're spinning at the same speed, he's going to go forward. If one motor is turning faster than the other, he's going to turn. If they're going in opposite directions to each other, he's going to spin around in a 360-degree circle. You can set this up so you can control it like a tank, you know, with 2 sticks. I'm going to set mine up for forwards, backwards, right, left. Again, I don't want to do anything different than what I'm used to when I'm flying a helicopter, you know, and this is your forward, backwards, right, left cyclic. So that's how I want to keep R2 configured as well. And here is the quick start guide for the Sabertooth, if you wanted to pause that to peruse it as well. Now this thing's rated at 32 amps, which is overkill, but it's the same price as their 24 amp one. So that's why I got it. Just a little more robustness, but even 24 amp would be overkill, especially for a 24 volt system. 12 volt system, yeah, you may want that extra current capability. Now this thing, this is a 3-pole relay. This is just the terminal block for it, but just a 3-pole relay. These are often referred to as ice maker relays for refrigerators. But what I'm going to use this for is to isolate the motors from the motor controller. That's why I got the 3-pole. So the 2 drive motors will be on 2 of the poles and the dome motor on the 3rd. And like I said, this is to isolate the motor controllers from the motors when the batteries are disconnected. Because both of these things, they are regenerative motor controllers. So when the motors are freewheeling or just spinning, not being powered up, motors act as generators. They create back EMF, sometimes pretty high voltages as well. You know, when you go to stop R2 or if he's rolling down a hill or something, the voltage that's created in the motors will be going back through the motor controllers and back into the batteries, which is great. The problem is when the battery is disconnected, when you turn R2 off, you know, you're breaking the circuit. So the voltage comes into your motor controllers, but it has nowhere to go now. And that can take out the motor controllers. That energy's got to go somewhere, and if it can't go into the batteries, it's going to burn something out in the controllers. So there's a number of ways to prevent that. One, don't roll R2 around or move his head when he's unpowered. I feel that's unrealistic because he's going to be heavy and you are going to be rolling him around. Some people put plug-ins in so they can disconnect the motors when he's unpowered, but that's essentially what this relay is going to do automatically. Whenever it's powered up, whenever R2 is powered up, the relay will be closed, and I'll just be taking one of the one of the outlines from the motor controllers into one of the poles and then out to the motor. Same for the next pole to the other motor, 3rd pole to the dome motor controller. When R2 is powered off, the relay will open up, breaking the circuit for all 3 motors, so any back voltage from them can't get to the motor controllers and damage them. And I'm going to be powering this relay off of the fuse that powers up my Sabertooth here. So if that fuse was also to blow, it would isolate the motors from the motor controllers immediately. I just wanted to add something really quick here while we're talking about relays. Anytime you're running a relay in a system with sensitive electronics, as would be the case with many R2 builds, really good idea if you use a snubber or flyback diode across the coil of the relay. And the reason for that is when you de-energize the coil in the relay, it creates an induction spike in voltage, and we can see that on the scope. Right now we're just seeing the scope reading the 24 volts that I'm going to be feeding this relay, and we'll just watch that. And you can see as the relay is de-energized, it's creating all this electrical energy and noise that's getting back into your system. And if we zoom in on the scope, what you want to look at is the peak to peak voltage, the minimum and maximum. You'll actually be surprised at the induced voltage that's created when this field collapses. You know, peak to peak voltage, 139 volts, 150, 142. So we're dealing with large amounts of voltage. Granted, it's small current, but certainly enough to take out sensitive electronics. Now, if we hold the little flyback diode, this is just a 1N 4004 diode, very common. The 4004 can snub up to about 400 volts, so certainly well within the range that we're seeing here. So I'm just going to hold it across the coil of the relay, just making sure that the band is on the positive side that we're feeding the relay. Now we'll watch the scope again as we energize and de-energize the relay. No more noise. It completely shorts out all that noise that's created across the coil. Take it off again, do this, and there we get all that noise back. So when in doubt, use a snubber diode across your relays. Your circuits will thank you for it. Seeing that we've talked about the motor controllers, better talk about the motors. Already covered the dome motor in part 5, but here are the 2 feet motors. And these are often referred to as e-scooter motors, rated at 100 watts. These are the 24 volt versions, of course, because I am using a 24 volt power system. You can also get them in 12. Again, that's kind of why you need to know what you're going to be powering R2 with before you start ordering any of this, because it will dictate some of the stuff you buy. And as you can see, at 100 watts, you know, continuous draw, that would be their maximum they'd normally draw. 24 volts, you know, that's just over 4 amps per motor. So he's sipping power. You know, obviously when you're changing directions, it's going to peak over that, but you know, it's not going to be pulling much current at all. And you can get these with 2 pulley options on them. You can get a belt pulley, these are metal, or you can get a sprocket. Now, because my R2 is the Mr. Badly printed version, I'm using the foot version 3, I believe, which is the gear-driven wheel. And, you know, you just print out the gear and it slides onto the motor shaft. It's got a flat and everything on it. You fasten it with the little screw and square nut kind of deal. The only issue with this, I should mention, I had a hell of a time getting the pulley off. You know, there's a C-clip on the top. Just thought, well, you pop that off and the pulley should pop off. But no, they actually use some type of a retaining compound on there, so the pulley is actually glued onto the shaft. So I actually had to heat this up with a propane torch. You know, you don't want to get it scorching. There's a bearing in these. These are ball raced. You don't want to overheat the shaft and cook the grease out of the bearing. Just warm enough, though, to soften the adhesive. And then I just got a little pry bar under there. And it just popped right off. No problem at all. So that pretty much covers the basics. This stuff is fairly easy to wire up. Right, into the dome here. So I know I already covered all the TC's lights and the hollow projectors in part 3, and I just mentioned in there that there was a few things left over, like the slip ring, which we already looked at in part 5. But now that I've got it all wired up, just thought I'd kind of show the final configuration of everything. I guess we may as well start here with this little servo-controlled switch. This is the same idea as the soundboard servo-controlled switch. Just have a 12-position rotary switch there, controlled with a servo. to give, you know, multiple switched outputs with one RC channel. This is what's controlling all the Cree LEDs in my holo projectors. So I can have the holo projectors turned off or turn the front one on, the back one, or the top one. And I've also got a switch position going to my TC's lights, so I can turn them on and off. I don't really know why I'd want to, but I suppose if I wanted to turn them off and back on, so that starting script would show up, it could do that. I figured I've got 12 positions. I may as well use 4 at least. And I've also got a relay here. That's actually what's controlling this TC's lights. Normally the relay is closed when it's not powered up, meaning the TC's lights are always being powered. But when I move the channel to the switch position that energizes that relay, the relay will energize and it will open up the circuit to the TC's lights, and that's how they reset. And I've got a variable voltage and current output buck converter on here that's used for powering the Cree LEDs. Again, there's 24 volts coming up into the dome. I've got the voltage dropped down to run the Cree LEDs at 3 volts and 750 milliamps. And then I've got the same, this is for the TC's light set. Again, it's being fed 24 volts, and I'm adjusting the voltage down to 5 volts for the TC's light set. I'm just using those clips, as I had mentioned at the beginning, to hold the wiring against the ribs so it's nicely organized and out of the way. It won't fall into the ring gear or anything. And then this is all being fed through this little harness that I made up that plugs into my slip ring plug up on the body. And there's just that little servo distribution board I had mentioned earlier. So I'm feeding the 4 holo projector servos and the servo for the rotary switch that controls the holo projector lights. And then it's also getting 24 volts. That's feeding power to the 2 buck converters, one to drive the Cree LEDs and the other to drive the TC's lights. So not complicated at all, but should do everything I need. So hopefully that gives you a few ideas on electronics. There's so many options, but yeah, that covers how I'm doing it. Might give you a few ideas of what you might want to use for your own, what you don't want to use. Thanks for watching, folks. We'll see you next time, and happy R2 building.